laws of absorption. We are having two laws. One is Lamberts law and second one is Beer's law. So both are related to absorption. When a monochromatic light, if you are passing through transparent absorbing medium, what will happen? The intensity of the transmitted light with respect to intensity of the transmitted light, the change in intensity of the light will be directly proportional to the thickness of the medium. Otherwise, simply you can write when a monochromatic radiation, if you are passing through a transparent absorbing medium, absorbance is directly proportional to thickness of the medium. This is known as Lamberts law. Numerically or mathematically, how will you represent the Lamberts law? Di by I equal to K into dx. That is what the representation of Lamberts law. And if you want to simplify this di by I equal to K into dx, we will be applying integration on both sides and we will be applying the lower limit and upper limit. Lower limit with respect to intensity I naught and upper limit I, that is transmitted light intensity. X is equal to 0, that is thickness 0, and X is equal to B, thickness B. Okay, that is the upper limit. And if you integrate it, integration of di by I will give us log I. And if you apply the upper and lower limit, log I minus log I naught, you will get log M by N we will be writing. That is log I by I naught. This is for LHS. And if you come to the RHS right hand side, if you apply integration of dx, we get x, and upper limit is b and lower limit is 0, and kb. The minus will be there because this will indicate the decrease in rate of intensity. That is a negative sign. So now if you want to remove this negative sign, we are multiplying both sides with negative sign. So now instead of writing minus log I by I naught, we will write log I naught by I. Log I naught by I equal to absorbance. Absorbance is equal to K into B. K is equal to constant, B is equal to thickness. Okay. Log I by I naught equal to transmittance. 1 by transmittance is equal to absorbance, or 1 by absorbance equal to transmittance. Okay, this is the simple representation of Lamberts law. A equal to K into B. And if you come to the Beer's law, when a monochromatic radiation, if you are passing through transparent absorbing medium, absorbance is directly proportional to concentration. Log I naught by I equal to K into C. So K or K prime is a constant and C is equal to concentration. I naught equal to intensity of the incident radiation, I is equal to intensity of the transmitted radiation, and K prime is coefficient, that is molar absorption coefficient. By combining this Beer's and Lamberts law, so what we get is we get finally A is equal to epsilon BC. In a monochromatic radiation, if you are passing through a transparent absorbing medium, absorbance is directly proportional to thickness of the medium and concentration of the medium. A is equal to epsilon BC. Why we are keeping epsilon? Epsilon is a constant. Epsilon is a molar absorption coefficient. Okay. This is Beer-Lamberts law.